to CESTiCC webinar. Rob Ament, a professor at Montana State University, will be presenting his results from his research project that was funded in part by the CESTiCC Grant Center, as well as the Montana DOT, I believe. And he will be discussing the evaluation of effectiveness and cost benefits of woolen roadside reclamation products. So Rob, I will turn it over to you.
Great, thanks Vicki. Welcome everyone. I'm glad you joined us to hear about a 3-year project where we explored different potential products to use that contained wool for roadside reclamation purposes. And I want to thank CESTiCC for hosting the webinar and supporting the project. The progenitor of this idea was the Montana Department of Transportation, and they sustained it for our research team for 3 years. I want to thank them, and as well as KC Harvey Environmental, who was a subcontractor and helped conduct the research and the field work. So I'll just briefly go through the project and some of its results. Let's see if I can get, there we go. So basically, we were charged, there was some evidence that wool was being used in other countries to increase vegetation establishment, not just on roadsides, but with horticultural applications and even sod roofs. So MDT was interested in seeing if there were any products here in the U.S. that we could use and do some demonstrations and research with, or if we could import some of the products from abroad. And so we were to develop and test these different products after we did some exploration. And the reason wool is considered a very a good candidate for helping plant reestablishment after roadside construction or disturbance was that, for one thing, it outperforms or holds way much more moisture. In the arid West, often our young seedlings dry out, and so it was looked at where wool can store up to 400% of its weight in water. It's way better than, for example, coconut core, which would be about 80% by volume for moisture. So the potential for wool to hold and make available to the young plants moisture either later in the day or for more days after a rain event was considered very promising potential for using wool. The other thing about wool is that it's a fertilizer, actually, as it breaks down. 17% of wool is actually nitrogen, and often for roadside revegetation, fertilizer is often needed because of the poor quality of the soils that the agencies are planting in. So although all that nitrogen isn't available immediately, as the wool breaks down over time, the nitrogen would be released in a form that could be used by plants. And the other thing is we had done a preliminary, before the project was accepted, and we did some preliminary background work. This was one of the sod roof matrix used in Germany. And as you can see, the coconut matrix, which is sort of the standard product that's used for erosion control blankets. Usually it's core, it's called core or coconut fibers with straw. And they compared that with using sheep wool, and you can see where the wool products were way outperforming the coconut when it came to vegetative coverage. And so this was very promising as well. And you'll also, I want to note on this that the lightest amount of sheep wool actually compared to some of the heavier amounts of sheep wool actually had higher percent cover of vegetation. So although the heaviest wool did end up with the highest results. So anyhow, we did want to look at different, like this project. In our project, we looked at different densities of wool or amounts of wool per square area. And then as we looked around the world, we were seeing that in some countries they were pelletizing wool and using it as a first fertilizer. This photo is New Zealand, where they were using pure wool blankets that were very dense. And so you can actually make wool so dense that instead of encouraging plant growth, it actually suppresses weeds and any kind of growth, so that on this particular project, they had containerized plants where they cut little openings in the very dense wool blankets. And then they also use a combination of wool with sheep manure as fertilizer as well. So all of these, the background information that we did made it look very promising that we wanted to try some things here along Montana roadsides. And so what we were specifically trying to do was identify which wool products would make the most sense for roadside applications. Then of those, we would actually do field tests. And then of those that were outperformed the standard products being used today by MDT, we would do a cost-benefit analysis. And so that's what I'm going to go through today. I don't want to go into detail with this whole list of products, but as you can see, we looked at international products. We looked at some existing horticultural products that were used here in the U.S., and ultimately we ended up producing our own for this project for a couple reasons that I'll explain in a moment. And so these are some of the things we would get test swatches. This is from New Zealand. It's actually a very dense wool. This is called Wulch, which is sort of a wood fiber and wool fiber combo mat. This actually we found out was to suppress plants rather than to encourage their establishment. And then a Montana wool mill actually made something. This is very similar to the New Zealand product. Again, what we were finding were all of the products that were currently being made were so dense as to become plant suppressants and wouldn't be very useful for our research project. So we ended up learning a lot about wool production because we had to produce our own products, develop and produce our own products, working in hand in hand with 3 different woolen mills here in Montana, and then an erosion control blanket manufacturer in Minnesota for the project. And just so when I use terms like scoured wool, these are scouring trains that actually, this is where dirty wool shorn right off a sheep is actually run through a whole series of hot water vats to take all the remove the lanolin, the wool, the dirt, the wax and oils on the wool, and dirt and feces and things like that. And also because of the hot water treatment, it gets rid of all the weed seed. So the clean product, what's called scoured wool, is actually hyperallergenic. And it's once you remove all those oils and waxes that allows the wool to actually retain moisture rather than shed it. Because we wear a lot of wool clothes that supposedly gets rid of the moisture, but in fact, until you clean it like this, it doesn't retain that 400% of its weight in water. And so this is just a quick picture of going in as dirty wool into a scouring train. This is the drying after it came out of the scouring train, and this is actually some of the product we used on this research project. We were not experts in wool production, so we really relied on the wool mills that we worked with to help us determine what to do and how to use their products. And these are, you'll hear about bats, wool bats, or carded bats. And so carding is basically machines that take those wool pieces and line up all the fibers relatively parallel to one another. So it's carded wool is basically where all the wool is aligned via these different machines. And this is what a final product would look like. And we actually would cut pieces of this in our, you'll see in our field experiments to look at different weights of wool to see which worked the best. And so we really had no products that we could import from foreign countries or that were really available here in the U.S. So we had to do a first season of testing of products. We didn't know what the right weights and densities of the wool should be. We also wanted to add wool pieces to compost, and we didn't know how much to add. So we spent a summer basically experimenting with colors, weights or densities, and then amounts before we actually did field tests. And here is a photo just so you can look at what, after it's washed, scoured, and shredded, what the wool product looks like up close, because you don't get to touch any samples, which I have plenty of, but on a webinar you don't get the tactile experience. And so what we found from that first summer is if the wool went on at too high of a density, it actually started suppressing a plant establishment. So it was very nice to know how many grams per meter squared we really wanted to work on with the wool companies to produce for our field studies in the subsequent years. So at the end of that first season, what we found was which products were we going to actually develop and field test. We found it was too difficult, or some of the products that we wanted to obtain, they didn't even have import-export license with the U.S., and there were no foreign products currently available on the U.S. market that were promising, so we didn't get to test any of those. That sometimes the wool capacity here in Montana, the production is quite small and very limited. And some promises for wool materials, when we'd ask different companies, we'd like to acquire some to test and get back to you, they just would not follow up with us even though we offered to buy them. And then, so we focused on wool weights and densities more so than on manufacturing processes, just because of, limited extent of what we needed to do in just 2 years. And then the final product selection was based on that previous photo of the field testing of different swatches of material. Pokorny Gardens is a very fancy name for one of our researchers' backyards. She had an acre and we tested it in her backyard. And so this is sort of a list of all these different products we reviewed. You can see there's a lot of no's, and the reason they're no's, we have comments on it. But what we did select were some of these different types of cut wool, felted wool, which felting means you actually take the carded wool, which is all parallel fibers, and you stick needles through it and pull them and move them. So you felt it and make it stronger and tighter material. So that's what felted wool is. And so we looked at other things, and ultimately we found an erosion control blanket manufacturer that would work with wool with us, and I'll explain that in a moment. So what we did was, we also, before we went out into the field, we wanted to lab test the materials to make sure that they were strong enough that they'd ultimately hold up for what Montana requires for roadside erosion control blankets. So we got the original run from the Minnesota manufacturer of some product, and then we sent those off to the labs, and they did a series of tests to meet MDT, which is basically also AASHTO or any other state, very similar requirements for erosion control blankets. And ultimately, after all the tests, we only did one replication because it was quite expensive, over I think $11,000. 3 tests are normal if you're a business, but we just did one set, and we found that it did meet most of the tensile strength standards for short-term or long-term. So it was fairly strong, and it exceeded some shear stress specified in the standard for short-term erosion control blankets, but not for high-level events, for like really gully washers, as they call them, or big storm events. So, and the C factor was also met type 2 erosion control blanket requirements by MDT. So overall, given it was only one test and not the full complement of 3, it was very promising that wool in these erosion control blankets could ultimately meet standards that would be required by a DOT. And so at the end of our first year, this is what we, after looking and trying and testing, we came up with the following 4 different areas that we wanted to explore. The first was the wool silt fence. We thought we could make it strong enough. It was 100% biodegradable and currently might be able to be used where the existing standard is woven plastic that doesn't decompose, and so there might be situations where 100% biodegradable silt fence might be needed. The second one was the erosion control blankets. These were pure wool, sort of like what we saw in New Zealand, and they were either wool bats or needle punch to make them stronger bats. That's a misspelling, sorry. And then also to use pieces of wool mixed with the standard compost used on roadside reclamation. And then ultimately we got into standard product development of rolled erosion control blankets, where we worked with a manufacturer and came up with different wool straw weights that I'll be showing you in a moment for the field test. And these were the products that we did the lab test on, the 50% wool, 50% straw rolled erosion control blanket. So the first product was silt fence. We thought, oh, they look pretty easy. You just stitch the bats together and put them up, and now we have 100% biodegradable silt fence. But and we had a nice location where they had just recently completed construction along US Highway 12, and so we set up 4 or 5 different fences along that, all of the same product. And ultimately it sags. As you can see, it wasn't uniform. There was inconsistent material density across the entire length or width of the product, and ultimately, just like a very wet sweater, it ends up sagging, and so it just didn't have the internal strength that would be needed to be ready to go. And so after a year, or by the fall, after all the storms of the year, we could see that we needed to go back to the drawing board and get some strengthener put into the wool felt. And so we had a tent making company here in town do different types of stitching, and then we also tried to add, maybe in between 2 layers of wool felt, we added some, this would happen to be plastic. We would ultimately use a biodegradable mesh, but some kind of mesh to try to strengthen it. We put that out the next year to see how well that would hold up, and as you can see, it was starting to sag equally, and basically had failed by the end of the growing season. So then we went back on the 3rd year, and instead of using wool, as the complete product, this is actually burlap bag material with a wool layer at the lower end to filter the silt. And so we thought the burlap would give it strength and the wool would give it the filtering effect, and it's still 100% biodegradable. And ultimately, that material didn't hold up very well either. And so we had 3 versions, and we concluded that it just needed a lot more work than what we could give it attention to as just one part of this relatively initial development study. So then the next thing we wanted to do was look at the different products in a field test. And this is a location on Highway US 287, and you can see it had failed. This had been an old construction site. They tried to re-veg it, and it had been done very poorly, or it had mostly weeds. And so we thought we would take our products and try it in a harsh site where already MDT had tried to re-veg and had failed, and would the wool products help in these very unforgiving environments. So we tested it here, and I'll be talking about, this is a compost test area. Each is 1 meter squared. This is the compost with wool pieces. You can see the standard coconut straw ECB that everyone uses today, and then you can see all these different combinations of different types of wool products, which I'll explain in a moment. But at least you can visualize what I'm talking about when I explain some of these different products. And so what we did was we wanted to test these by measuring the vegetative cover of the actual seed mix that we put down under the blankets, the erosion control blankets, or the compost with wool, and was it statistically significant? So we did a power analysis, and that's how we came up. We had done some previous erosion control blanket and vegetative studies for MDT, and so using that previous information, we developed a power analysis and came up with we needed 11 replicates to get statistical power, hopefully. And then the second piece, besides the ECBs, is we wanted to look at compost as well and do the same thing, test compost as the control versus compost with wool pieces. And due to our previous summer, we knew the relative rate of wool to compost. And so this is just some quick pictures as we were establishing the plots. And then to make everything the same, we put a mesh, a biodegradable cotton mesh over every single treatment, just so that it was consistent. And it was a windy site, so we didn't want to lose compost or wool pieces or other material. And so this is what it looked like after we got done setting up all the different randomized plots. Somewhere, so it was a block, random block design. So as you can see, some treatments are at the bottom of the slope, some were at the top of the slope. So it varied, some were on the east and some were to the west. So we varied it across the slope, and we used the same, this is a typical perennial grass seed mix that MDT uses. So we use the same seed mix on all our test sites at a seeding rate that the MDT reclamation specialist uses. So we're just trying to basically mimic what MDT does for roadside reclamation when it comes to seed mix. And so here were the different treatments. We had a lot of controls, as you can see, 4 different controls, but we did have 6 different ECB, potential ECB, I should say. Some were the carded wool blats, some were needle punched at different passes, meaning at different strengths. If they got too tough, we were afraid they might suppress plants. And then we also had the rolled erosion control blankets that were developed in Minnesota by that manufacturer. So these 4 were from wool. The first 4 products were from wool companies here in Montana. The other 2 were from the Minnesota manufacturer. And then, of course, we tried the wool compost at a 40-to-1 ratio. So originally at the previous summer at the test site, we did 20-to-1 and 40-to-1. It was quite clear that we didn't need to put that much wool into the compost. And just to give you an idea, when I talk about the manufactured erosion control blankets, you can see where this is a view of the actual production of some of our wool straw ECBs. This was a pure wool ECB being built, and this one is actually one of their standard straw coconut ECBs being made. So they were able to just put different wool and straw combos ratios in their hoppers to get the different mixes of how much of wool to straw for us to test in the field. So basically, from this site, we have traditional products that, products that could be simply replacing the standard coconut ones with wool ones. It was all made at the same dimensions. You could make 100-foot rolls just like traditional product. And again, because you can't feel or touch these today, I tried to give you a close-up. This shows you 64 wool combo, and this is the jute netting that's on the 2 sides. And the ratio 60-40 is weight of wool to straw in the layer between the 2 nets. So you can see a net on top, there's a net on bottom, and then you have your mix. And we tried different ratios of that straw to wool mix. And so going back along to use some of these 1-meter sections to be consistent instead of full rolls, we laid them out on US 287. And you can see after 1 year, we just, some vegetation was coming in. There's a saying that you sleep, creep, and leap. The first year, you basically don't have anything. The second year, you start getting some vegetative establishment. And then the leap year is when you really start getting some vegetative cover. And so you can see after 1 year, we didn't see a whole lot of veg cover. But by the second year, you can see we're getting very robust coverage on the site with that seed mix. And so these are the results from testing those 6 different products, erosion control blankets, and then looking at the compost and compost with wool. And so instead of going through every single thing, I'm going to point out what's highlighted to show you. This would, if MDT would have done their standard coconut erosion control blanket over their perennial grass seed mix, they would have gotten 4.7% cover of the seeded grasses after 2 years. But if they would have used either the 50-50 wool straw ECB or the 100% wool ECB, they would have got 4 to 5 times more vegetative cover of that which they seeded. So you can see this is a significant increase in vegetative cover by using the manufactured ones. And even if they would have used the different carded ones made by the wool companies, they were all above the 4.7 except one. And that was where, when it was needle punched, meaning 4 passes, 4 times, it got so tough or strong that it was hard for plants to probably penetrate through the felted wool. But ultimately, almost every single one but one product, by having wool in it, had higher cover of the seeded grass mix. The second one, desired, these would be volunteer seeds that are either in the seed bank or that came in via the wind, which were really just sort of a mix of information there, but we did categorize it. And there's not much of a story to tell there. Then the other thing we wanted to look at were the weed species. we were feeling that most weeds are broadleafs, and so the cotyledons might not be able to make it up through the wool because of the density of the wool. So it might suppress weeds compared to the traditional type of coconut coir, ECB. And so again, if you look at what they had, this again, if MDT would have used standard product, they would have had 17.7% cover in weeds, and only 4 of preferred what they planted. If they would have used these new products from the manufactured erosion control blankets, you can see they had less weed cover in both products compared to what is standard today. Now, we did want to do statistical tests on these differences in means, and so what we did was pair-wide t-tests, and that means we would compare each product with each other product. And so the p-values I have here for the seeded native grass are p-values when compared to the control of coconut, the standard coconut blanket versus the wool blankets that we produced. And you can see we had such low p-values that these differences of 4 to 5 times more vegetation are statistically significant. However, when we looked at the weed differences of 10.8 to 17.7 or 13.6 to 17.7, the p-values are high, so high that we really don't have any, they're not statistically different. So we can say a lot, at least for this, we can statistically say these are significantly different when it comes to the vegetation you want to establish. However, the suppression of weeds, although different, was not statistically different. And then the last part of the story of the field test at 287 was comparing the compost with cut wool versus just compost alone. And as you can see, again, the wool had about a 60% increase in preferred seeded native grass, what you planted, by just adding the cut wool pieces into it. It also had a bit more weed cover, probably because of the nitrogen effect or the moisture holding effect of the wool. So you have more vegetation establishing when you use the cut wool. However, again, comparing the cut wool to the control of compost only, the p-values for both seeded and weeds was not statistically different. So we, again, it's promising, but we don't have any statistical power to say it was more, but it was 60% more, but that wasn't necessarily statistically significant. So then what we wanted to do, we had another field test of the erosion control blankets. These just jumped out at us. We were and really made a wool something that could be commercially available almost immediately. You could go into production at any erosion control blanket manufacturing plant and put wool into your hoppers and be producing this kind of product if, as a manufacturer, you were interested. So we have a test slope at our research facility in Lewiston, Montana. And what we wanted to do is try different combinations of wool ratios and compare that to the standard coconut straw. On this, there's no topsoil on this slope. Again, we wanted, and it's we built it so it's south facing, so it's the harsh, dry, and very poor soil. And we thought, well, if wool could help plant establishment, that would be great. It could only get better in nicer sites. So as you can see, we did, again, random blocks. We had 10 replications, so we just kept going down. These are 5 meters long by 2 meters wide, and we did 10 reps of all the different types as well as the control, and ran it for 100 meter. This whole slope is 100 meters long. So we were able to have total control over randomization and our different types of wool combos compared to the coconut. And this is, again, after year 1. You can see there's a lot of weedy species established in year 1 and 2. It's such a harsh site. And what the results from this showed, we just weren't getting anything that was significant. And the seeded grasses, it took 2 years before they even began to establish, and the wool was starting to decompose by the second year to start providing sort of a nitrogen effect, I guess, or a fertilization effect. But again, we had no statistical significant differences in any of the treatments after 2 years. So we extended the project so we could go back a 3rd year, and these are the 3rd year results. So what you can see is that, again, let's go to the control, which is the coconut. You'll see that we had, of the seeded perennial grass mix, there was 28% cover under coconut. If you had the pure wool, again, only a 4% more preferred veg cover than the standard. And as you can see, some of the wool were underperforming the standard, but the 50-50, relatively 50-50 one that we had used at the other site also was 32. So if you remember, 50-50 and 100 at the previous field test site outperformed the coconut. These two mixtures again outperformed it. By trying to go to lighter amounts of wool, it seems like it was unsuccessful. So somewhere between 50 and 100% seems to help plant establishment. Although again, we did not get statistical significance on these. And then both the non-seeded and the weed seeds, weedy species covers were quite similar, and there wasn't much of a story to tell about that. It was sort of a wash, 6, 6, and 5, so 5% cover. So weeds, there was no difference. There again was more coverage in the 50-50 and the 100, but that we could not determine a statistically significant more amount of cover. So what you can see is, look at the vegetation that came in by the 3rd year compared to what I showed you a picture of previously of just 1 and 2 years. So it does take some time before the plants get established and you get incredible cover. But what was interesting is I wanted to show you, these are the 2016 results versus 2017, and look at the weed seed coverage. It went from 29 down to 4, 31 down to 6, 30 down to 6, and a significant decrease in the weed species in 1 year, and then of the planted, significant 20 or 30% increases, 20 to 30% increases in cover of the seeded native grass. So it really did go from creep to a big leap by year 3. And we're unsure if the weed reduction was due to someone spraying it. There's a contractor that sprays around the roads in the facility and might have treated this slope, or if it was due to competition with the seeded native grasses. But the story still was that the 50-50 and the 100% wool ECBs did have more cover in what we wanted, which was the seeded grass species. And the other thing we found after 3 years was there was still some bits and pieces of wool. You can see it right here. It takes about 3 years for the erosion control blanket to decompose, which really does provide quite a bit of good cover, but also means that over 3 years, the wool's slowly breaking down and releasing its nitrogen into the soils. And so then the other thing we wanted to do was look at the cost benefit of using these wool straw combos. Again, we focused on the 70% standard coconut ECB and the 50 and the 100. If the less wool you use, you know it's going to cost less than straw. So the 50-50 we compared. This was from the site where we had statistical difference. That was the first field test area along US Highway 287. And what we found was it cost, we worked with the manufacturer about buying wool versus buying coconut and putting it into the ECBs and manufacturing it. And so this is the manufacturer cost. It includes shipping for production. In other words, bringing the wool that was cleaned here in Montana back to Minnesota for production purposes, where they don't bring coconut from here, they get it through their traditional means. And what we found was I'm sorry, I have this in the wrong place. This is actually includes shipping for production, the same as with the wool too. So we did try ask him to include costs of getting it to Minnesota, regardless of whether it was the coconut or the wool. And what we found was by using wool at a 50-50 ratio, that it costs just slightly under twice as much. So the initial cost of buying the ECB is twice as much if you use a 50-50 mix in your ECB. However, so that's one way of looking costs, just at the upfront installation cost. But if you look at how much cover, responding cover you get by using the wool, remember it had 4 to 5 times more cover than the coconut, and you look at the cost of buying this with the response of how much cover you get, then actually the 50-50 straw ECB costs about 5 cents for each percent vegetative cover per meter squared for each one of those test meter squareds that we set up. And if you use the traditional, it's cheaper up front, but you also get so much less vegetation cover that it actually costs more for each percent veg cover. Again, because you're only getting 1/4 or 1/5 of the veg cover that you're getting for the 50-50 straw. So you can look at have a results cost or an upfront installation cost. And if you look at it this way, it's expensive. If you look at it this way, the results are worth investing in, even though it costs more upfront. And then this was not part of the project. I've done this subsequently because we forgot to add, or we didn't, at that time that we didn't add wool as a fertilizer. Like how much money would it save if you use wool versus use coconut and then have to fertilize as well? Well, so this is a very busy slide. I apologize for this, but the bottom line is I looked at some traditional, if you send your soil sample in, the lab returns it and it says you need to apply 3 pounds of nitrogen. This is a very typical poor soil here in the northern Rockies. And such a lab, but when you get your lab results, if you're doing a reclamation project along a highway, and they say, well, you need 3 pounds of nitrogen. Well, that's for 1,000 square feet of area. The equivalent is you need to apply 130 pounds of nitrogen per acre. So if you use a coconut, you would have to pay not only for the fertilizer, but also to put it out, to apply it as well. And there's all different types, from liquid ammonium like agriculture uses to granulated broadcast types of fertilizer. But if you use the 50-50 wool straw ECB, it basically produces 411 pounds of per acre of nitrogen when you put the wool ECB. So you can see it's about 3 times as much. But if you remember from my previous slide, it takes about 3 years for the nitrogen to decompose. So basically what that says is you're getting about 130 pounds per year from the nitrogen in the wool blankets being released or decomposed and released and made available to plants each and every year. While you may pay for fertilizer for 1 year because it is very mobile and readily available, and then it disappears by the second year, most of it does. With wool, you're actually getting the same fertilizer effect year 1, year 2, and year 3. And in part, this may be a rationale for why we were seeing higher levels of veg cover by year 3 with the wool blankets than we were with the coconut blankets. So I guess that's the last slide, and that basically is the whole project. And in summary, the silt fence was very complicated, and really, I believe you could make a wool-based silt fence that's 100% biodegradable, but it takes more for manufacturers to continue to work that out and get it really down to cost effective. Burlap's very cheap and might be the type of material to be working with more so than wool. The second product that we really wanted to look at was, could we add wool pieces to compost? Clearly, you were seeing a response rate of 60% more. It was only one test site. Yes, it was 11 replicates of each, but we still did not find that the amount, the 60% more, was statistically significant. We believe that that's an easy product to explore further about the right combos and do enough field testing to get some statistical power behind it. For the erosion control blanket, it became clear to us that economically you wouldn't want to use pure wool blankets like what the wool mills here in Montana produce for us. It just would be prohibitively expensive, and even though you could get a higher vegetative response rate, you couldn't afford to pay for it ultimately. However, by just using cut pieces of wool and mixing it in with straw in a traditional rolled erosion control blanket, it'll most likely meet the type 2 erosion control blanket requirements or specifications of DOTs. It might, with a little further exploration and more testing, hit type 3 erosion control blanket specifications. And if so, we demonstrated that it can outperform. It certainly always gets more vegetative cover, whether it's statistically significant. We found it in one area on one test site and not the other. So again, it's not absolutely overwhelming evidence, but there's a lot of good information here that demonstrates that wool in smaller amounts, but yet some, basically 50-50 means 8 ounces of wool per square meter of material, could give you much higher vegetative cover. And again, we only tested it in Montana environments. And that's only one type of place. We never were able to go to, say, the arid Intermountain Basin where cheatgrass is problematic and where dryness, cheatgrass robs the soil of the moisture before the native plants can establish, or any other type of challenging roadside project where you're trying to reestablish vegetation. So what we feel we concluded was it definitely provides a benefit. We can show in one instance where it was statistically different, it also is economically justifiable. And on another, we didn't. So I guess you could say we had somewhat mixed results, not overwhelming results, but almost every time we used, as you saw, when we used some wool, it was outperforming the coconut products. Thank you. Now I'm available for any questions.
Anybody have questions? You either can raise your hand. I can unmute everybody if you all want to try talking at once and see if there are any questions. Any questions? Okay. Well, thank you, Rob. I will stop recording now. And thank you all for coming.